Hello and welcome back to the vectors section of the SQ Higher Maths course. We are going to have a look at position vectors today. So what is a position vector? Well, vector OA is called a position vector of point A relative to the origin being 0, 0 or 0, 0, 0 if we're in 3 dimensions, and we write that as little a. OB is called the position vector of point B, and that's written as little b. And for point P, which is at XYZ, that would be vector OP or little p underlined, and that would have components x, y, z. So to move from point A to point B, we can go straight from A to B, but we might not know how to get there. But what we could definitely do is do the negative of vector A, which would take us to the origin, and then add on vector B. So again, if I'm at point A, this is kind of going the long way around. I could do negative A to get to the origin, and then plus B. So that would be AO plus OB, or negative OA plus OB, which is negative A plus B, or we could write that as B minus A. So we could generalize that for the vector joining any 2 points, P and Q. Vector PQ to get us from P to Q would equal little q minus little p. So here, if I wanted to get from A to B, I could do B minus A, and that would give me the directions from A to B. Let's have a look at an example of that. So we've got point R, we've got point S. So these are coordinates because they're written horizontally. So R to S would just be little s minus little r, or vector S minus vector R, I should be saying. So that'd be 4, 6, negative 1. Notice I'm writing it in vector component form here. Minus 2, negative 2, 3. And then it's just 4 minus 2, 6 minus negative 2, and negative 1 minus 3. Okay, so vector RS is just vector S minus vector R. Question 2. PQRS is a parallelogram. We're given points P, Q, and R. Calculate the coordinates of point S. Okay, so I've drawn a diagram here. I've drawn a parallelogram. PQRS. So I've gone from P to Q to R to S. We've got to go around in that order. Okay, we can't just say this is P and this is Q over here, because that will lead to problems. So draw them out. You could go, which way would that be? You could go clockwise instead. That would be fine if we're just drawing the diagram. So if I want to find point S, 2 ways of doing it. I could find out how to get from Q to R, and then add that onto point P. Or I could find out how to get from Q to P, and then add that onto point R. Either way, I'd get me to S. So what I've actually done is to get from O to S, or just to find out where point S is, I'm doing O to P. So I'm going from the origin to point P, then I'm going from P to S. So I know because it's a parallelogram, P to S will be the same as Q to R. So let's find out vector QR. So that'll be R minus Q, which will be 11, 2, negative 1. So then to get from the origin to point S, I'm going to go to point P, then I'm going to add on vector PS, which is the same as vector QR, which we've just calculated. So that'll be 169 plus 1, 2, negative 1, which would give us 288. Remember, that's a vector. That tells us, if we're starting at the origin, how to get to point S. But what we actually need to do is write out the coordinates of point S. So that must be written horizontally. That's what's been asked for. So we need to write S as 2, 8, 8. Okay, right guys, so have a go at the questions from exercise 5B.